Hello, welcome back to the Dora Woodman YouTube channel. I'm Jason. So today we're looking at the Vaillant Arotherm Plus range. In front of me here we've got the Arotherm Plus 7 kilowatts. This is going to be going into a new build project that we've got coming up over the next few weeks. We've had this delivered and ready to go. It gives me an opportunity to kind of show you guys what the Vaillant Arotherm Plus is all about, go through a few of the guidelines, some of the data, and give you an opportunity to kind of take a look at what to expect from this kind of unit. Okay, so the Arotherm Plus comes in a number of sizes to suit new builds and retrofit respectively. We've got a 3.5 kilowatt, a 5 kilowatt, a 7 kilowatt, there's a 10 kilowatt and a 12 kilowatt. Now the 3.5, 5 and 7s come as a single fan unit, as you can see in front of me. The 10 kilowatt, 12 kilowatt are the double fan units, which are slightly bigger and larger, and this also means that they do not come under the permissible planning permissions. So what I'm saying is, so on a single fan unit, usually a single fan unit will give you allowance to use that unit under permissible development. You don't need planning permission. Once you get to a 2 fan unit, or double fan unit, the increase of the capacity of the heat pump means that you're required to apply for planning in order for you to have that heat pump in place. Typically as well, if you've got a listed building, if you live in a listed building, or you're kind of a conservation or a place of natural beauty where you're not really meant to put anything on the outside of your home, again, planning has to be considered before you can put in renewable heating technology, particularly when it comes to heat pumps and something of this nature which is going to sit outside the property. Typical package is that for this one in particular, this is a new build, it's a 4/5 bed, depending if they use the study as a bedroom house. It's on 3 floors. Ground floor is going to have underfloor heating. The next 2 floors will have radiators. So we needed to come up with a package that would enable us to be able to zone each floor and control the heat on each floor. So the underfloor heating on the ground floor will be operated by the underfloor heating manifold and its wiring centre. There'll be actuator heads, and we'll use something like a heat miser wireless controller to heat each room. There's 4 rooms downstairs that will need to be controlled. Then we get up to the first floor. Now, as you'll see here in a box, I haven't taken it out because it's quite well packaged, we've got the hot water cylinder. This is a 250 litre hot water cylinder. This will be placed upstairs in an airing cupboard or a cupboard which the client has chosen to locate this. And what we will do, we will put in our interface wiring centres, and on that floor also we'll be able to control our heating. Now, the way in which we'll do that, we have what we call a Senso Comfort. This Senso Comfort is an internet-based heating thermostat and control, and also it's kind of brains as to how you would set up the heat pump for its flow temperatures, hot water temperatures, Legionellas. Everything that we need to set up for your heat pump, for your home, is done by this controller. This can also act as a room thermostat, or a thermostat for a floor. So for instance, we'll put this on the first floor in the location of the heat pump, of the cylinder, sorry, and then that will be able to control that zone for heating. We'll also have added an extra control for the second floor, which will then control the heating for that upstairs as well. So each floor is zoned, and we've got the capacity in which to do so and independently turn on and off the heating. Also comes with, this is an outdoor sensor, so this will have to be outside, and this will read the temperature outside to offer its weather compensation. The warmer it gets outside, the heat pump will react to that, and your heating temperature inside will reflect what's happening on the outside. So if you've got if it's very cold, it's a winter's night or a winter's day, say 1 or 2 degrees, you've asked for the radiator system to have a 50-degree flow temperature. At them temperatures, it's going to look to provide 50 degrees if that's how you've set it up on your heat curve. when you start getting to warmer temperatures, you might get to say between 8 to 10 degrees. It might decide then that, looking at the way that we've set up the heat curve, looking at the flow temperature, could be looking at anything between, I don't know, 35 to 38 degree flow temp. Really depends on how we set it up and the fabric of the building and how warm you need things to be. We set everything up depending on the variables of your home. You don't want this directly in the sunlight, so because it will read the outdoor temperature. So if you imagine the sun's beating on it, could actually be 4 degrees outside, but when the sun is on it, could maybe change that by quite a few degrees. Even up to say like 10, 11 degrees, depending on how warm or strong the sun is at the time. So this will need to go in more of a shaded area as such, normally north facing if you can do so. Also have a buffer vessel. Often, we've got a fair bit of heating involved and there's a lot of volume of water in the home. So the buffer tank itself, or the buffer vessel, gives you, it helps with hydraulics and pressurization of the systems to help maintain equal flow rates, or that the heat pump doesn't start becoming inefficient or short cycling because of the way the flow rates are affected. So essentially it gives you like your open circuit. So for example, if you've turned off radiators and you haven't got kind of an open loop and all your underfloor heating, or you've got underfloor heating on both floors, all your thermostats are shut down, and there might be a pump overrun and it's got to just continue just to kind of keep the temperatures so that it's not just sort of stuck inside the heat pump and going nowhere, gives it a chance to overrun and give it a cooling down period. Your buffer vessel actually will help maintain that. Also help that bypass getting back through from this buffer back to the heat pump, and keeps this open loop going. So it's got many benefits. It can also be used, or will be utilised, when you're using the heat pump, particularly in the winter time. It's working quite hard, and where your air comes in from the back, you've got a fan at the front, it's blowing the air out. As that's pulling that air through, it's taking out the energy. And often it then gets very, very cold and starts to become a bit icy, and ice starts to form around some of the, you don't often see this unless you're looking very closely. Then when it drops to a certain temperature, or it reaches a certain temperature point, then it has to go into a defrost. So it will use some of the heat energy that's generated to defrost that, and then you get this condensate water coming from it. You may notice that if you haven't had the condensate drain put onto the bottom of the unit, it might start puddling. Or we would say to put in a gravel pit or something in and around the heat pump to allow that to soak away. And what it can do is use the buffer to withdraw some of that heat to come back for its defrost without affecting the heating system. So it works in many applications dependent on the application in which we've put it into, the situation that we've put it into. That's 100 litres. Dependent on, again, it all comes down to the kilowattage, how much kilowattage you're using for your home and how big your system is, as to what kind of size we would end up using for the buffer vessel. In fact, this is a 45 litre, sorry. In some applications we'll use 100 litre. The electrics and communications, again, it's just a case that we would put all the wiring centre together. We work off of the electrical schematic and work out exactly what we would be, what we would need for each floor. Generally speaking, you need a power supply to the unit. This will be for a 7 kilowatt. It's around about 25. Actually, it might be 16 amp for the 7 kilowatt. When you get to the larger units, it's a 25 amp rotary isolator switch. It will also need a communication cable, which will be from the interface. So there's a bus cable, Cat5, shielded as well to stop anything interfering with its frequency as it gets from one point to another. And that will basically just talk to the machine and tell it what it requires it to do. So if it's in hot water mode at that time, it will ask for the hot water demand, tell us to turn on, and it will do whatever it needs to do. So it's reading all of the sensors that are attached to the flow and return temperatures. There'll be sensors in the cylinder as well, so it reads the temperature of the cylinder. You might be asking for a 50-degree heat for the cylinder, and you might have a setback temperature, so that the setback temperature basically says at 40 degrees, when it drops to 40 degrees, we want the heat pump to regenerate that hot water cylinder. You know, and that's what the sensors are doing, because they're reading what's going on all the time, and it will then talk to the heat pump and tell it when it's required for heat or hot water. Again, you could set a timed program if that was more efficient for you or more to your liking, and you can get the program to run, you know, whether you prefer to have something running very early in the morning or in the middle of the night if you find that you might have cheaper electricity tariffs. So it's quite versatile, there's lots of options available. With every heat pump, when you do an install, it's important that you take the right measures in your approach as and kind of the pre-installation process. One of the processes, particularly for MCS reasons, if you're applying for a renewable heat incentive, for example, our paperwork has to comply with everything in order for you to do this. And if we were asked to produce this paperwork, we need to make sure everything's in line. There is a DNO, which is basically your district network for your electricity. You just need to notify them if you're putting a heat pump in, and particularly if you're replacing a fossil fueled appliance, or a gas boiler, an oil boiler, or something like that, because the electric demand for the house is going to change. So what needs to be considered is that, have you got the right capacity of your home that's going to be able to deal with the electrical content of this heat pump, the currents that is going to be required for it to work. They have to make sure that they know what is being applied to each and every household, because as more and more homes rely more on electricity for everything in their home, they need to make sure that they've got the electrical supplies available, so it keeps a record of everything that's going on. There was also considerations as well. So if you're doing a new build, for example, you might have everything running off electricity in your home. So you've got lighting, you've got induction hobs, you might have an instant boiled tap that you're going to use in your kitchen, you're going to have your cooker, your heating system's going to be running off of it. Obviously you get Legionella, so you're going to have an immersion running off of it, kettles and computers, and people have many lights. Yes, they're used for on LED, so they're low energy, but everything is electrified. So the bigger the capacity, some people might need or require or want air conditioning in their home. So if you start working on properties or doing developments out in the sticks, for instance, or maybe it's on an old farmland, and they might have a really old electrical supply in there. It's very important to make sure that your electrical supply will meet the demand in which you require for things such as heat pumps. Particularly, we've seen instances where they've had all of that electrical requirement needed, and even to mechanical heat and recovery systems as well. And looking at the subboard or something, the electricity that's coming into that property, towards that property, is very old, and instead of a single phase, they actually required a 3-phase. And then it comes to a whole different process of making sure that the 3-phase is available, how much it's going to cost you in order to get 3-phase. So there's lots and lots of considerations, and that should really be done before you've even broken ground if you're doing that on a new build. So definitely something to consider. The refrigerant inside of the heat pump is a different refrigerant to a lot of the refrigerants that are available at the moment. The older style heat pumps, and we've touched on this on another episode, and I'll put up the data for each and every scenario, but some of the older units, NEBI still use it, is an R410A. That's one of the older refrigerants, and that's got a higher global warming potential. They're moving across, or most manufacturers now are moving across to R32. That has a slightly lower global warming potential. There are more, it works at a slightly higher efficiency, works at different pressures. You don't need as much of the refrigerant in the heat pump, so that offers you kind of better efficiencies because the heat pump doesn't have to work as hard to be able to produce the same amount of heat. The Vaillants use an R290. Now, this is a flammable propane refrigerant. So we've discussed this before, but there are areas in which you have to be considerate about the placement of the heat pump in consideration for doors and windows, for example. Now, generally speaking, and you'll see on the screen now, there are requirements as to distances that you have to be away from certain areas. The reason being is that the refrigerant is a heavier gas than air. So if you're within a vicinity or outside of the parameters of where this heat pump needs to be situated, so I mean, generally speaking, for example, so this between point A over this side of the heat pump to the other side, there has to be a radius, a range from each end of about 3.1 meters from like a drain or a couple of doors or a door and a drain to stop this refrigerant being able to get into those areas. Now, it can accumulate, and because it's a flammable gas as well, it can be potentially dangerous. If it's near a drain and this was to leak, and it's very, very rare. I mean, this isn't, the circumstances for something like that to happen to a heat pump, it really doesn't ever often happen, but it can happen. These heat pumps are double cased as well around the compressor and the refrigerant, where all of the components are that store the refrigerant. So that just means that if there was a failure of the pipework or something happened, then it's got a double casing to really store that refrigerant in to reduce any risk to any person or persons or wildlife or environments or whatever. So they have to be considered, and you'll see that. And then as it gets up to kind of its higher level, the range it gets a bit smaller, and that would be from the top height. You'd have to have about 2.1 meters of distance between point A and B, so this kind of whole area, and that's being away from windows, etc. Now, I did say that the gas is heavier, and it's heavier than air, so it would drop. So, why would it affect a window? Well, these gases work at higher pressures. So if you imagine, even if water comes into your home at 1 bar, if you pierce a tiny hole in that 1 bar of pressure into that pipe, the water will spray upwards before it drops. These refrigerants will be at working pressures of anything between 20 to, it can work up to, permissible is up to 30 bar. That is really quite a high pressure behind it. So you can imagine a small piercing of sorts could come out, go to a height first before it starts dropping. So that's why these considerations have to be made. So this will, obviously make considerations for your placements if you're looking to use the Arotherm Plus. Obviously, the double height units, the higher they are, the more considerations you have to take into account as well. That's also applicable to the electrics. So we would require a rotary isolator very near the unit itself. It means that we can isolate the power and do any maintenance work or any works to touch the electrics. We can isolate it within its vicinity locally, and it makes it a safer environment. However, you have to be outside of a certain range of the heat pump, because if that was ever a leak and there was a spark, it could ignite. But again, these are just safety measures, and it is nothing to worry about as such. So we'll have a look inside the unit in a moment, just to kind of show you where this double casing goes and why it's there. Generally speaking as well, the heat pump will sit on anti-vibration feet. They're just rubber feet. There's a picture on the screen of those. And that just basically keeps it solid. There's going to be a little bit of vibration going on, just purely on the basis that you've got fans and everything kind of rumbling, but these will be working at very low level sounds. So the smaller units will be working between sort of 45 to 46 decibels from a meter away. The larger ones are around about 52 decibels because they've got a double fan on there. But again, we've got examples of when these machines are operating, and they are very, very quiet. Okay, so as it stands, you just got your electrical points coming in to the rear of the heat pump. You've got your mains electric coming in, which will be here. This will come from your rotary isolator switch, which will go to this, which will then power the computer board. And then you've got your points where you've got your, what we call the bus cable or the communication cable, which interacts with the interface. And just down there, you've got your connections to your flow and return water, basically the warm water going out into the building and the cooler water coming back for regeneration. Then just inside, I mean, as a you know, an end user or client, you won't need to worry about this, but just kind of show you the anatomy of the heat pump itself. So just in front of us, we have the compressor. That basically does all the work, where it takes the refrigerant, goes from a gas to a liquid, and starts to help to generate that heat, which is then transferred through a heat exchanger at the very back, where you'll have one side, which will be your refrigerant heating up the water, and the water heating up on the other side, coming in cooler, going back out hotter, and providing the heating and hot water. Has a pump on the inside of the heat pump itself, and that helps just obviously push that water up into the house, you know, to the cylinder, where you'll find that you'll have diverter valves and pumps and everything that's supplying the heating throughout the home, and also supplying the hot water. So pretty basic. As I said, the anti-vibration feet sat here. I mean, this polystyrene isn't normally here. We just got the packaging still on as we're looking at it. The fan is on the other side of here. So your fan will be spinning, drawing that energy from the back through here, straight out through the front, blowing that out. So your ambient temperature from back to front will be 10 to 15 degrees lower, depending on, you know, how the heat pump's working. This basically is what collects the energy from the air. This will extract that energy, pass it through the refrigeration process, and then whatever warmth it takes out, which is why you get this ambient temperature where it's cooler at the front of the heat pump than it is at the back, because it's extracting and drawing that energy through that refrigeration, going down into the compressor, converting that to useful energy for your home. Well, thank you for watching. I hope this has been informative for you. We've put some data up just to show you kind of how things perform. The SCOPs on these Vaillants will range from between 3.5 to 4.5. I mean, at very low temperatures, it really does depend on the flow temperatures inside your homes. If you're using or installing underfloor heating, you'll be running at a much lower output of your flow temperature, and obviously your insulation values should be excellent. If you're in a new build, that means that there's less energy required in order to provide your heat, and you could be looking at 4.5, 4.8 SCOP, which is your coefficient for your heat pump. It's been a pleasure to show you this video and to show you some of the content in which we supply. If you've got any comments, anything that you would like to know, any further information maybe about this product, or just heat pumps in general, if there's anything you'd like me to touch on when it comes to videos and content for you guys to watch, please let me know. I'll be happy to have a look and see if there's something we can fulfill for you. Hit that subscribe button so you get all the latest videos that are going to be coming up, and if you click on the bell as well, you'll get notified as soon as something new comes available. We've got plenty of content to come. There's lots of stuff in which we will talk about. If you'd like to visit us on www.doreywoodman.co.uk, please feel free. You can leave some questions there if you'd like to. And we'll see you on the next video. Take care.